For eons, the night sky was a silent tapestry, a beautiful, unreachable fire. We asked if we were alone, and the cosmos answered with nothing but darkness. But today, 26 light-years away, that silence has finally cracked. This isn't a radio signal or a message from an alien civilization. It is something more visceral. It is a chemical ghost. Meet JWST. It is a super-Earth, a heavy scorched world orbiting a violent red sun. It's a place of extremes, where the surface is hot enough to melt lead and the gravity would crush your bones. By every law of science we knew, this should be a dead, airless rock. But as the James Webb Telescope turned its golden eye toward this furnace, it saw the impossible. A signature, a dip in light that belongs only to the molecule of life. Water. In the heart of a cosmic wasteland, we found the one thing we thought was ours alone. The question isn't just how it's there, it's what it means for the billions of other monsters hiding in the dark. How can a world that burns at over 800 degrees Fahrenheit hold on to the very thing that defines the coolness of Earth? This is the paradox that has sent shockwaves through the global scientific community. If there is water on JWST, it defies every model we have of how planets live and die. We are standing on the threshold of a discovery that suggests the universe is far wetter, far more resilient, and far more desperate to harbor life than we ever dared to imagine. It challenges the very definition of a dead world. The star at the heart of this mystery is a red dwarf. These are the most common stars in the Milky Way, yet they are notoriously violent neighbors. Unlike our sun, which provides a steady, nurturing glow, red dwarfs are temperamental giants. They lash out with solar flares and high-energy radiation that can be thousands of times more powerful than anything our Earth has ever experienced. For a long time, the consensus among astronomers was grim. Any planet orbiting such a star would be stripped bare. We believed their atmospheres would be sand-blasted away by the stellar wind, leaving behind nothing but airless radiated husks of rock. We viewed these systems as cosmic graveyards, where the seeds of life were incinerated before they could even take root. Yet, as JWST crossed in front of its star, something miraculous happened. The starlight filtered through the edges of the planet's atmosphere, and the James Webb Space Telescope captured that light, breaking it down into a spectrum, a barcode of the elements. Within that data, the researchers found the unmistakable peaks and valleys of water vapor. This was not a faint hint or a statistical shadow. It was a clear signature. The question now haunting every laboratory and observatory is, where is this water coming from? If the star is constantly trying to destroy the planet's atmosphere, how can the water still be there? It is as if we found a pool of liquid at the center of a blast furnace. But what if the water we are seeing isn't actually part of the planet at all? What if the universe is playing a cruel, high-stakes trick on us? This is the chilling alternative that scientists are now forced to consider. Red dwarfs are covered in star spots, colossal dark patches of concentrated magnetism. In these cooler regions of the star's surface, water vapor can actually form and linger. As the planet passes in front of these spots, the telescope might be seeing the star's own moisture and mistaking it for the planet's air. We could be staring at a cosmic mirage, a trick of light played by a star that refuses to reveal its secrets. We are caught in a detective story where the primary suspect might be the light itself. To find the truth, we must look deeper into the heart of the planet. If the water truly belongs to JWST, it implies something revolutionary. It suggests that the planet is not a dead static rock, but a living geologically active world. For an atmosphere to survive the constant bombardment of a red dwarf, it must be replenished from within. There must be a heartbeat. Deep beneath the cracked, glowing crust of this super-Earth, there could be vast reservoirs of volatiles being pumped into the sky by titanic volcanic eruptions. The water we see might be the planet's own internal lifeblood, bleeding out into space in a desperate automatic attempt to maintain a shroud of air. This changes everything we thought we knew about the habitability of our galaxy. If a planet as battered as GJ486b can maintain its moisture, then the billions of other planets orbiting red dwarfs across the Milky Way might also be holding on to their air. Suddenly, the number of potentially habitable worlds in the universe doesn't just increase, it explodes. We are no longer looking for a needle in a haystack. We are looking at a galaxy that might be overflowing with the precursors for life. We are seeing a universe that clings to water even in the face of stellar fury. A universe that refuses to be empty. If this planet has managed to shield itself, if it has held on to its water against all odds, it forces us to ask a terrifying question. What else is hiding in that steam? On Earth, water is the stage upon which the dance of biology begins. While GJ486b is likely too hot for life as we know it, its existence proves that atmospheric resilience is possible. It means that just a little further out from these red suns, in the slightly cooler regions we call the Goldilocks zone, there are worlds where that water doesn't turn to steam, but falls as rain. We are looking at the proof of concept for a billion alien oceans. Imagine a world where the sky is a permanent, bruised purple, dominated by a sun that never sets but hangs forever in the same spot in the heavens. On the day side, the heat is unbearable, and on the night side, the air freezes solid into glaciers of nitrogen. But in the thin ribbon of twilight between the two, the Terminator line, the water we found on GJ486b could pool into vast, dark seas. This discovery is the first piece of a much larger puzzle. It is the bridge between our world and the billions of twilight worlds that populate the dark. We are learning that the harshness of the cosmos is not an absolute barrier. Nature finds a way to harbor the ingredients of life in the most hostile environments imaginable. As we stare at the data from 26 light years away, we are also looking into a mirror of our own past. Our Earth was once a molten ball of rock, battered by the early sun and bombarded by comets. We are the survivors of a chaotic and violent birth. Seeing water on a world like GJ486b reminds us that Earth is not a miracle of isolation, but a participant in a common cosmic process. The chemicals that make us who we are, the hydrogen and oxygen that flow through our veins, are the same chemicals currently swirling in the scorching winds of a distant alien world. We are connected to the stars by a river of steam that spans the void. But there is a profound loneliness in this discovery. We have found the water, but we have not found the life. We are looking at a neighbor's house and seeing that the lights are on, but the windows are fogged and the doors are locked. Is anyone home? Or are we simply watching the automated processes of a machine that has no operator? The distance of 26 light years feels smaller than ever, yet the silence of the universe feels heavier. If water is common, if atmospheres are resilient, then where is everyone else? Why does the abundance of water not translate to an abundance of voices? This is the central mystery of our time. The more we find that the universe is suited for life, the more confusing it becomes that we haven't heard a whisper from the darkness. GJ486b stands as a sentinel, a silent witness to the laws of physics and chemistry that govern the entire cosmos. It tells us that the ingredients are everywhere. The table is set, the water is poured, but the chairs remain empty. Or perhaps We simply haven't learned how to see the guests. We are looking for footprints in the sand, but we are only just beginning to understand the nature of the sand itself. Every time the James Webb Space Telescope sends a packet of data back to Earth, it is a testament to our own insatiable curiosity. We are a species of explorers who have spent most of our history confined to a single island. Now, we are learning to navigate the ocean of space by reading the ripples in the light. We are beginning to understand the climate of worlds we will never walk upon, mapping the geography of the invisible. And in that mapping, we are finding that the universe is not the cold, empty void we once feared. It is a place of activity, of change, and of water. The discovery of water vapor on GW4EAU6b is not the end of a journey, but the start of a much more profound investigation. We are waiting for the next set of observations, the ones that will tell us if the water is truly volcanic, or if it is a gift from the star. We are waiting for the moment we find a world that isn't just wet, but temperate. A world where the water doesn't scream into the vacuum as steam, but laps quietly against a shore. We are 26 light years away from a revelation that could redefine our place in the hierarchy of the heavens forever. We used to think we were the center of the universe. Then we thought we were a fluke, a 1 in a billion accident of chemistry. Now we are beginning to see the truth. We are part of a vast interconnected web of matter and energy. The water on GJ486b is a bridge. It is a signpost pointing toward a future where we are no longer alone. It tells us that the universe is prepared for us, or for something like us. It tells us that the darkness between the stars is not a wall, but a medium, filled with the very things that make life possible. As we look back at the pale blue dot we call home, we realize that our ocean is just one of many. Our rain is just one version of a cosmic cycle. We are standing on a small pier, looking out over a dark sea, and for the first time, we have seen the glimmer of a wave on the distant horizon. The universe is not silent. It is breathing. It is waiting. And it is much closer than we ever imagined. What if the water we find on these distant worlds isn't the beginning of life, but the remains of it? What if we are not the first to look out at the stars, but the last ones left to wonder?